You said that familiarity makes things easier to reason about. Are there any other tips, or are there any other things from neuroscience where you think, okay, this might be useful to apply to AI to help AI reason better?
Familiarity makes things easier to reason about, especially if you are a neural network, where neural networks are so expressive. They're capable of learning such a broad array of functions that what they're going to do on data they've never seen before is kind of unconstrained, because they could learn to do something different on that data if you wanted them to. Their expressiveness is deeply tied up with their ability to learn complicated things. Their expressiveness is tied up in their what they might, that we don't know what they're going to do on unfamiliar data. So recasting things as familiar is particularly important if you want like a statistical learning system like a neural network to do a good job on reasoning problems. I think a thing that I think about a lot from the perspective of like benefiting, like augmenting the current state-of-the-art large models is the role of memory and how it's different in humans. The way that we think about like the role of episodic memory, of rapid memory contributing to the learning in the brain is actually like quite similar to how we think about retrieval augmented generation, like RAG in these language models, that if you give them access to a memory buffer in which you can just put entire new experiences that they could then draw and add to their context, that's actually like pretty, like kind of in a lot of ways very similar to how we think about learning in the brain. And I think both like neuroscience and AI could find that an interesting and fruitful analogy. A big thing I think is that the process, like one thing I really like about Andrew and Ishita's paper on comparing language model reasoning to human reasoning is that it demonstrates that like one lesson for thinking about the relationship between AI and neuroscience, or AI and psychology, is that it's really hard to evaluate how good a model or a brain is at doing stuff. And the entire field of psychology has really like spent a lot of time trying to really tease apart how the brain solves different problems. What kind of like really, it's difficult to quantify and to systematically say things about how an intelligent system is working. So I think that comparing, using the brain as a reference point is a really useful way of calibrating expectations. Like, should we say this is good? Should we say this is bad? Like, well, let's make sure using humans as a reference point is really helpful for just calibrating our expectations. And then the processes by which we tease apart how the brain works, which is the job of neuroscientists, or how behavior works, which is the job of psychologists, has a lot of complexity to it. And I think there's a lot of interesting reuse of methods that will eventually go into that.
You mentioned that it's sort of difficult to quantify how a brain does all this sort of learning and memory and things. Should we be using different metrics for AI then? Should we just be saying, okay, this should have a completely different system to it? How do you think about that?
A lot of what goes on is that people will play around with language models and then post something on Twitter, which is a single example. And then people read into it and post it around. And then somebody will try prompting in a different way, and you don't get that same effect anymore. This approach has pros and cons, honestly. I mean, I think there's something clearly anecdotal and therefore not super scientific about it. However, it's almost kind of like field research. Like it's lots of people playing around and trying different things and finding things. And those constitute good hypotheses for what kinds of things we should look for. I think the mistake perhaps is like confusing like single examples with conclusions rather than using them to inspire hypotheses. And I think that's really like, you hear a lot about the scientific method, which starts with a hypothesis and then constructs a scheme to evaluate it, an experiment to evaluate it. Where these hypotheses come from is a little bit of a fuzzy story. And, people trying different stuff, people having experiences in their lives, people just kind of thinking random thoughts is a big part of that historically, I think. And, some hypotheses just strike people as interesting questions and some don't. And I think that this process is really good for generating hypotheses. Actually evaluating them is tricky. I have there's a lot of work that goes into this. I don't necessarily want to say like, I don't want to say like people are doing it wrong. People are trying really hard to come up with evaluation systems to try and quantify what these models are good at. If they're good at reasoning, if they're good at math, if they're good at critical reading comprehension. They're using tests that we use on humans, and which is very much kind of building with a psychological approach. And then when they pass this test, then they start to think, well, wait, where does that test fall? Like, let's try to make new tests as a result of it. So it's, in some sense, I don't think anybody's doing anything like fundamentally wrong. It's just a hard process. I think that's one of the lessons. It's just like really hard and requires a lot of investment to come up with good evaluations of how these systems work, and to really like calibrate expectations and test hard hypotheses about how models are working.